Hello, welcome to Huawei Lightboard video. I'm Christopher Jans, I'm Technical VP and Director of Huawei Canada's Optical Systems Competency Center. Today I'll explore technologies for reducing equipment, energy, space rental costs, and fiber leasing costs on data center interconnect. Data center interconnection devices generally use a muxponder that integrates the line side and tributary side functions. To facilitate deployment, mainstream muxponder devices in the industry have evolved to 1 to 2 RU fixed configuration devices, which can be stacked like pizza boxes to expand capacity. The cost of the muxponder board mainly comes from the line side optics, client side optical modules, and the board basic framework. The cost of line side optical modules accounts for 80% or more of the total cost. To reduce the cost of line-side modules, the single wavelength rate and performance need to be improved to reduce the per-bit cost by using the most advanced processing, optimal modulation technologies, and the most efficient FEC algorithm. For example, Huawei's ODSP channel-matched shaping modulation technology is used. The CMS technology first detects the transmission performance of real channels to obtain the channel impairment model information. Then the transmit end compresses and shapes optical signals to match the transmission channel model, and the receive end compensates and corrects the received optical signals to recover data. The shaping, compression, compensation, and error correction algorithms are based on the real channel impairment model. The built-in algorithm automatically optimizes the settings to achieve the real-time dynamic self-optimization of the transmission link. In addition, the CMS can quickly iterate channel model parameters to improve the precision of the channel model and achieve better channel matching effect. The entire optimization process is automatically completed by the ODSP chip without manual intervention. The encoding shaping method for coping with the noise penalty is as follows. Probability constellation shaping, PCS. High-quality constellation points are selected by directly changing the probability of each constellation point. Hybrid bit shaping, HBS. The quality of each constellation point is improved based on a certain proportion of mixed encoding types. On the other hand, improving hardware integration has become the trend. For example, the high-density design enables a single fixed configuration DCI device to support electrical layer boards. Industry-leading vendors such as Huawei have achieved 9.6 terabits in 2RU, saving cabinet space. In addition, multifunctional integration of optical layer boards is also an important method for improving integration. For example, Huawei has integrated the functions that need to be implemented by multiple boards, such as the optical amplifier, multiplexer-demultiplexer, optical signal monitor, VOA, and OTDR into one board. In this way, only one box is needed in each direction, and only one board is needed in one direction in the 8-channel small capacity scenario, greatly improving integration and reducing space occupation. To save space, one device supports both optical layer and electrical layer boards. Fully utilizing the slot space of the device is an effective method for improving integration and reducing space occupation. Huawei DCI is used as an example. In the 8-channel 600G scenario shown here, traditional devices require 4 RU or more of rack space, while only 2 RU is required by Huawei DCI. The DCI WDM box can be installed in a 600 mm depth. The CT cabinet or enterprise cabinet that supports optical amplifier sites and electrical regeneration sites can also be placed to save space. In summary, advanced coherent algorithms such as CMS can reduce the cost and power consumption of WDM equipment. In addition, the following are effective methods for reducing space occupation: electrical layer and optical layer boards that are highly integrated and share the same platform, and support of 600mm cabinets. Fiber rental cost is a major part of the capital expenditure. A longer distance leads to higher fiber rental cost. In addition, fiber resources are insufficient. The following three methods can be used to improve fiber utilization. Wider spectrum, more subcarriers, higher modulation format, and higher baud rate are three ways to increase the capacity of optical ports. Currently, the maximum supported modulation format is 64 QAM, but higher baud rate and more subcarriers increase the channel bandwidth. In terms of high single wavelength rate, the DCI application in the industry has developed from 100G 200G to 400G 600G, and there are a few such application cases. The evolution to 800G will start in 2020-2021, and then to 800G, 1 terabit, and 1.2 terabit. On the other hand, fiber spectrum resources need to be fully utilized, from the existing C-band to the extended C-band, and further to the super C-band, to upgrade from 80 to 96 C-band channels to 120, and further expansion to 120 channels in the C-band plus L-band in the future. Technical breakthroughs are needed in system components, such as hardware design, algorithms, chips, lasers, receivers, and amplifiers. For example, Huawei implements the cursor wavelength blocking algorithm on the muxponder board and implements the 120 C-channel optical amplifier on the OA board.